chapter number 18, and chapter number 18 is beta about gas laws. So basically here we will be studying about gases. Okay, so beta, before we start studying this, actually, can someone tell me the kinetic theory of gases? Shabash beta.
So the particle's kinetic energy increases as the temperature and pressure increase.
Okay, beta. So the kinetic energy of gas, kinetic theory of gas says basically gas is made of large number of, tiny particles, atoms or molecules, right, beta? And beta, they are in continuous random motion. The molecules of the gas have random motion. Okay, right, right, beta. Beta, can you
Yes.
hear me? Okay, and beta, uh, so the molecules of the gas, they continuously collide with each other and with the walls of the container. Okay, and beta, as the temperature increases, we know that the motion of the molecules increases, their kinetic energy increases. Okay, beta.
Okay, sir.
Okay, so they already studied in chapter number 17, right? Now, beta, we're gonna study about gas laws, and basically, beta, gas laws are merely the relationship between these three properties of the gas. So beta, you should understand what are these three properties. Means you should understand what do you mean by pressure of gas, what do we mean by volume of gas, what do we mean by the temperature of gas, right? So beta, do you know what do we mean by volume of gas? You know what is volume?
Area, volume is.
Beta, volume simply we define volume, the amount of space occupied by an object. Okay, that is called the volume of the object. Clear? Yes or no?
Yes.
Yes, sir.
Now, beta, here we are talking about volume of gas. So simply, beta, the space occupied by gas is called its volume. And beta, but you should know, we have studied about that earlier, that gases do not have a fixed volume. Right or wrong?
Yes, sir.
Yes, sir.
Okay, so beta, and we also studied in the properties of the gas that gases, they take the shape of whole of the container, means they fill the container they are in. So basically, the volume of the container the gas is in is the volume of the gas. Right or wrong?
Right, sir.
Now, beta, you understand what do we mean by the volume of gas? You know this now? Yes or no, beta?
Yes, sir.
Yes, sir.
Next, beta, the temperature. Okay, beta, we also studied about temperature in a previous chapter. We defined temperature. Can anyone tell me what is temperature? Shabash, beta. Beta, we did that just in the previous chapter. Temperature. So beta, temperature is the measure of average kinetic energy of the molecules of a substance. Right? Right, beta?
Yes, sir.
So temperature is a measure of average kinetic energy of the molecules of a substance. So beta, simply temperature of gas means the measure of the average kinetic energy of the molecules of a gas. In simple understanding, simply, to understand the concept, you can say simply it's how the molecules in the gas are moving. Okay? Getting my point or not?
Sir, getting a point.
So beta, temperature of gas is clear?
Yes, sir. Yes, it's clear.
Now, beta, the next we're going to discuss pressure of the gas. Beta, this is very, very important. Very, very important. Repeatedly asked question in the past paper as well. So please listen carefully. And sometimes it is 2 marks, 3 marks question. Okay, sometimes 1, sometimes 2, sometimes 3 mark question. Okay, beta. So when it is 3 marks question, so you have to write the details. So that's why listen very carefully, beta. Okay. Okay. Now, beta, how do gases exert pressure? Okay, or pressure of gas. Beta, like we discussed the kinetic theory of gas, we discussed that the gas molecules of the gas they are in continuous random motion, right, beta? Yes or no? Ji beta, molecules of the gas are in continuous random motion. They collide with each other and with the walls of the container. Right or no?
Right, sir.
Yes, sir.
Okay. So now, beta, how do gases exert pressure or pressure of gas? It's very important to understand. Pressure of a gas. Okay. Now, beta, so the molecules of the gas, let's say they are in a container. Okay, so we know that the molecules are moving randomly, so they continuously hit at the walls of the container and rebound, right? Now, beta, how do gases exert pressure? Beta, simple. When the molecules of the gas beta, they hit the wall of a container and rebound and bounce back. What happens, beta? Okay, first of all, beta, you need to understand gases exert pressure due to the collision between the gas molecules and the walls of the container, right? Beta, when gas molecules they hit the wall of the container and they bounce back and they rebound, what happens, beta? Their velocity changes, yes or no? Their direction of motion changes, yes or no?
Yes, sir.
And beta, if their direction of motion changes, it means their velocity changes, yes or no?
Yes, sir.
Okay, and beta, if their velocity changes, you know their momentum changes because we have studied momentum is equal to mass times velocity. Momentum changes if velocity changes or mass changes, right? So their momentum changes. Yes, beta.
Yes, sir. Yes.
And beta, we have also studied, if you remember, that force is equal to rate of change of momentum. So if their momentum changes, so it means they exert a force. Okay, which is equal to mv minus mu over t. Okay, beta, because force is equal to rate of change of momentum, so it means they exert a force on the walls of the container. Getting my point or not? Ji beta.
Yes, sir. Getting a point.
Okay, so beta, if they exert a force, so we know that when force acts on a unit surface area, pressure is equal to force divided by area. So beta, that force when is exerted on a unit surface area of the container, so that exerts a pressure. Is that clear or not?
Sir.
जी बेटा.
Clear, sir.
Now beta, if you want to describe in one word, okay, what causes pressure of gas, or how do gases exert pressure? Shabash beta, how do gases exert pressure? Shabash beta. Shabash beta. Anyone? Gases exert pressure. Pressure due to the collision. जी बेटा. Collisions
Collision of the molecules with the walls of the container.
between the molecules of the gas and the walls of the container. So beta, basically the pressure of gas is due to the collision between the gas molecules and the walls of the container. Okay, this is main reason why gases exert pressure due to collision. Now this is, if you have to answer right, like you have to write the answer only for 1 mark, so you will write this, getting my point. But you know, if you have to further explain it, okay, then beta, what will happen? Means, how would you do that? When the gas molecules hit and rebound from the walls of the container, so beta, when the gas molecules hit, they hit the wall of container, and then beta, what happens? Hit
They
and
exert a force on the container.
rebound, right?
Yes, sir. It
When the
reacts.
gas molecules hit and rebound from the walls of the container, beta, what happens? Their momentum, ji beta,
Changes.
Increases.
momentum changes. Their momentum changes. Okay, and beta, as their momentum changes, we know that rate of change of momentum is equal to, yeah, rate of change of momentum is equal to force, right? So their momentum changes. So beta, which produces a force which produces a force. And beta, you know, you also have to write the equation which produces a force. You can write F equal to mv minus mu over T, which produces a force F equals mv minus mu over T, okay, on the walls of the container. Okay, beta. Any doubt or confusion?
No, sir, no doubt, no confusion.
Okay. Now, beta, so this force, it is this force divided by the surface area of the container, which results in pressure. Okay. Or you can simply write container, it is this force which produce or which causes pressure as P is equal to F over A. So beta, is that clear now? It's very important beta. Sometimes it's 3-mark question. And beta, it's important here, so main point simple. So gases exert pressure due to the collision between the gas molecules and the walls of the container, right? So when the gases, obviously when they collide and they bounce back, when the gas molecules collide and bounce back, beta, what happens? Their momentum changes. Okay, and when their momentum changes, so they exert a force which is F is equal to mv minus mu over t. You have to write this equation as well, because there are sometimes 1 mark for this equation, right? So F is equal to mv minus mu over t. So this exert force, and for pressure is force per unit area. When force is acts on a unit area, so when force acts on a surface area, force per unit area is the pressure. So that's how gases exert pressure. So is that clear to everyone?
Yes, sir.
Now, beta,
Yes, sir.
here, very important point to understand, beta. Very important point to understand. Okay. Now, beta, so gases exerts pressure due to the collision between the gas molecules and the walls of the container, right? Now, beta, if there are more collisions in a unit time, if there are more collisions, means collisions become more frequent. What will happen? Pressure will, shabash beta, pressure will increase. Understand, beta?
Yes, sir.
Okay, and beta, if the collisions are harder, means during each collision molecule exert a greater force, then even then the pressure would become higher, right or wrong?
Right, sir.
So beta, simple, you need to understand, more frequent collision, higher pressure, harder collision, higher pressure. Understood?
Yes, sir.
Okay, beta, till here any doubt or confusion to anyone?
No, sir.
Okay, so beta, now see, is this third one, pressure of the gas, clear now?
Yes, sir.
Okay, so now beta, what we're gonna do now? Now we're gonna do um, one of the laws of which is Boyle's law. We're gonna discuss Boyle's law now. Okay, beta. Boyle's law. Actually, beta, in this chapter, basically what we're gonna study, we're gonna study about what is the relation between pressure and volume of the gas, what is the relation between volume and temperature of the gas, and what is the relation between pressure and temperature of the gas, right? So these relationships are called gas laws as well. Okay, now beta, here you need to remember one thing. Beta, you listening to me or not?
Sir,
When will we do
Yes, sir.
Charles' law?
Beta, actually Charles law is not in syllabus, but basically Charles law is the relationship between volume and temperature of the gas. Okay, so I will tell you about the relationship between, but actually will not do like as a law. I will tell you what you need to know according to your syllabus. Okay, beta.
Okay.
Understood?
Yes, sir.
Yes, sir, understood, sir.
Okay, so beta, so basically we are gonna study here what is the relationship between pressure and volume of the gas, volume and temperature of the gas, pressure and temperature of the gas. And beta, to in understand the relation, you needed to first understand what do we mean by pressure of the gas, what do we mean by volume of the gas, what do we mean by the temperature of the gas. So that's why I did those first. Now I hope that you know what do we mean by pressure of the gas, volume of the gas, and temperature of the gas, right?
Right.
Right or wrong, beta? Okay, now, so beta, remember whenever we study relationship between two quantities, beta listen, whenever we study relationship between two quantities, the third quantity is kept constant. Third quantity is kept constant. Beta, whenever we study the relationship between two quantities, the third quantity is kept
Constant.
Constant. Constant.
shabash, shabash. Now, beta, what is Boyle's law? Beta, simply Boyle's law is the relationship between pressure and volume of the gas. It is the relationship between pressure and volume of the gas. So beta, if we are studying the relationship between pressure and volume of the gas, it means the third quantity, which is what? Temperature, it will be kept? It will be
Constant.
kept constant. So temperature it will be kept constant. Okay, and beta, remember when we study the relationship between these quantities, we will always consider a fixed mass of gas. Okay, we will always consider a
Fixed
we
Fixed
mass of
mass of
gas.
gas.
always consider a fixed mass of gas. Okay, now beta, we're going to study the relationship between pressure and volume of the gas. And beta, I've already explained you pressure, and I also told you what pressure of the gas depends upon. Pressure is basically due to the collision between the molecule. Now how many collisions are there and how hard each collision is, that's what the pressure depends upon, right? Okay beta, right? So
Yes,
beta, in
sir.
order to understand that, what we're going to do, we're going to consider this a container, okay, or you can say a cylinder, okay, and beta, it has a movable piston. The piston is movable, means we can move this piston up and down. So obviously beta, when we move, and it beta, it contains gas molecules, right? So okay, okay, now beta, let's say uh, here the gas has a certain volume. We know that the volume of the, you can say, container is basically the volume of the gas, right? Now beta, if we move this piston up and down, so what will that do? If we move this piston up and down, what will that cause to be? Beta, that will cause the volume of these are identical containers, right?
It will exert more pressure.
Beta, I'm not talking about pressure now. So beta, when we, let's say, I push the piston down, let's say halfway down, right? Now beta, what will happen? See, the volume of the gas has
Decrease.
decreased, right? I'm considering the same amount, same mass of gas, right? Now volume has decreased. Now beta, what effect will it have on the pressure? We are studying the relationship between pressure and volume.
Higher
When
pressure. Higher pressure.
okay, shabash. So simple. And beta, why? How does the pressure become increase? Here beta, temperature is kept constant, okay? And you know,
Pressure increase because It has a small area, so it will bounce more on the walls.
Yeah, I'm going to talk about it, beta. But here few things. Okay, so beta, when see here in this case, there are certain number of molecules in a unit volume. Okay, so so there are certain number of collisions on unit surface area of the walls of the container, and that results into a certain pressure, right? Now, beta, if the collisions become double, okay, let's say beta here we have just numbers. I'm just using those numbers for the sake of explanation. Let's say beta here this the pressure 1 atmospheric pressure, right? And you know what is 1 atmosphere? It's about 100,000 pounds. Pressure and the volume of the gas here is okay. Let's say it's 100 cubic centimeter. Okay, understood, beta? Now, beta, I just push the piston down until the volume of the gas is now,
Double.
no, volume is now 50 cubic centimeter. So basically now the volume has halved. Now, beta, like you said, I think everyone could easily appreciate if we decrease the volume pressure of the gas, volume of the gas decreases, the pressure of the gas increases, right or wrong?
Right, sir.
Okay, and beta, why is that? You can easily see beta when the volume of the gas decreases, there are more molecules in a unit volume, so there will be more collisions in a unit area on unit surface area of the container, so pressure would be more, right or wrong? Right or wrong, beta?
Right, sir.
So beta, actually, if I have reduced the pressure volume of the gas to half by pushing this piston downwards, right? So it means there would be twice the number of molecules in a unit volume. So there would be twice the number of collisions per unit area. So the pressure would be double. So if well, the volume is 50 cubic centimeter, what would be the pressure of the gas? It will double to atmospheric pressure, right? Getting my point or not? Beta, getting my point or not?
So getting your point.
Yes, sir, getting it.
Okay, so beta, simply if we decrease the volume pressure of the gas, if we decrease the volume of the gas, pressure of the gas, G beta, pressure of the gas,
Increases.
and if we increase the beta, if we'll increase the volume of the gas, what will happen to the pressure?
Decreases.
Decreases.
Decrease. So beta, simple. When the volume of the gas is increased, its pressure decreases, right? And when the volume of the gas is decreased, the pressure of the gas increases. So now beta here, but also remember beta here, a very important point, this increase or decrease is not in any order, means this increase or decrease is in certain proportion. You know what it means? It means if we halve the volume, pressure just not only increases, but pressure becomes double, right? And if we double the volume, pressure just does not decrease, it becomes half. So beta, so what are such relationships called? What is such a relationship called?
Directly proportional.
No. Beta, directly proportional is when one increases, other also increases. One decreases, other also decreases in certain proportion. That is directly proportional relation. Here, what happens if we increase the volume? If one increases, the other decreases, and if volume decreases, the pressure increases. Means if volume becomes half, pressure becomes double. If volume becomes 1/3, pressure becomes treble. If volume becomes double, pressure becomes half, and so on. So beta, what are these relationships called? Inversely proportional, right? So beta, remember, inversely means inverse. When we say two quantities are inversely related, are you listening to me or not? I told you that in when we studied Hooke's law, I also told you that in detail, and I'm telling you again here because it's important. Beta, there is a difference between inversely related quantities and inversely proportional quantities, right? Similarly, directly related quantities and directly proportional quantities. Getting my point? So here I'm talking about inversely. So if one increases, other decreases. One decreases, other increases. Then it is we say two quantities are inversely related. But better that if that increase or decrease is in certain proportion, means if one becomes half, other becomes double. One becomes one third, other becomes treble. Then we say they are inversely proportional. Understand, beta? Understand?
Yes, sir.
So
Yes.
here, beta, these quantities are not only inversely related. Basically, they are inversely proportional. So beta, what we can say, the volume is in. So pressure is inversely proportional to. Ji beta, pressure of the gas is
Volume.
inversely proportional to volume, and that's how we write inversely this relation. Now beta, if pressure is inversely proportional, and remember that beta, whenever two quantities are inversely proportional, always remember beta their product is a constant. Like I told you, when two quantities are directly proportional, their ratio is a constant. Similarly here, when two quantities are inversely proportional, their product is always a constant. Okay, so PV is equal to constant. And beta, it follows that if PV is equal to constant, it means that product of pressure and volume will always be same, right? For this here, and beta, this constant of proportionality, it varies. It could be different in. Okay, so beta, I guess the time is up. So I didn't realize the time of the class is over. So beta, so today I think what we have discussed, we discussed till here that pressure of the gas is inversely proportional to the volume of the gas. Okay, beta. Someone just texted me that sir, the time of the class is over. So fine, beta. I'm gonna conclude the class. Inshallah, rest we'll discuss in our next class. Okay, beta.
Okay, sir.
Allah Hafiz, beta.
Yes, sir.
Hafiz, sir.
After, sir.